Hi, for this activity we have to determine the gradient of the curve f, which is equal to 4x to the power of 3 minus 6x minus 4 at the point where x is equal to 2. So we have to remember from our previous video and from the previous lessons that the gradient of the curve is the derivative of the curve, which can be computed in a specific point, for example in this case in the point x equal 2. So as a first step, what we have to do is we have to determine the derivative of the function f. And to do so, we apply the rules that we have seen so far. And so we see that the derivative is 4 that multiplies 3 that multiplies x to the power of 2 minus 6, which is equal to 12x to the power of 2 minus 6. This is the derivative of the function f. Now we have to compute the derivative in the point x equal 2. So what we do, we substitute to all the x's in the derivative the number 2. And so the derivative in the point 2 becomes 12 that multiplies 2 to the power of 2 minus 6. This is equal to 12 multiplied by 4 minus 6. This is equal to 48 minus 6, which is 42. And this is the gradient of the curve f in the point x equal to 2. Let's see. The second part of this activity asks, is the graph increasing or decreasing at this point? Well, we have seen that the derivative of the curve in the point x equal 2 is positive. And this means that the curve is increasing in this point. And this is the solution of this activity 2.1. Now let's see the activity 2.2. The activity 2.2 asks us to calculate the gradient of the tangent to the curve g at the point x equal minus 4 if g is the function minus 3x to the power of 2 plus 5x plus 2. So we have this function and we have to proceed as we did with the activity before. So we have to compute its derivative, which is minus 3 multiplied by 2 multiplied by x plus 5. This is equal to minus 6x plus 5. But now this is the general derivative of the curve. Now we want to compute the derivative in the point x equals to minus 4. So we substitute to all the x's that we find in the derivative the number minus 4. So this becomes minus 6 that multiplies minus 4 plus 5. This is equal to 24 plus 5, which is equal to 29. And this is the answer. This is the gradient of the tangent to the curve g in the point x equal to minus 4. Let's now have a look at the activity 2.5. The activity 2.5 says, given that the function g is x to the power of 3 minus 6x to the power of 2 plus 9x, is g increasing, decreasing, or stationary in the following x values, x equals to 1/2 and x equals to minus 1? So we have this function g, and we need to see if in certain values x, this function is increasing, decreasing, or stationary. And to do so, what we have to do, we have to compute the derivative of the function g in the values and see if this derivative is positive, null, or negative. And so we will know if the function is increasing, stationary, or decreasing. So let's start from the function g. We compute its derivative, which in this case is equal to 3x to the power of 2 minus 6 multiplied by 2x plus 9. This is equal to 3x to the power of 2 minus 12x plus 9. This is the derivative of the function g. Now we compute the derivative of the function g in the point x equals to 1/2. And so we substitute to all the x's in the derivative the value 1/2. And so this function becomes equals to 3/4 minus 6 plus 9, which is 3/4 plus 3, and this is equal to 3 plus 12 divided by 4, or equal to 15/4. And this is the value of the derivative in the point x equal to 1/2. Now we also have to compute the value of the derivative in the point -1. So we do the same, we substitute to all the x's in the derivative the value -1, like we can see here, and this becomes equal to 3 plus 12 plus 9, which is equal to 24. This is the value of the derivative of the function g in the point -1. Now, since the derivative in these 2 points, x equals to 1/2 and x equals to -1, are both positive, which means that are both larger than 0, then the function in both values of x is increasing, because the derivative in these points is positive. We can now have a look at the function, at the activity 2.6. We have a certain function h, and the activity asks us if h is increasing, decreasing, or stationary in the following x values, which are x equals to -3, x equals to 0, and x equal to 3. So we have our function h, and we proceed as always. So we have to compute the derivative of the function and then compute it in the specific x values. So first of all, we have a function in which there are some parentheses, so we can do the multiplications in the parentheses, and the function, if we do all the multiplications and all the steps, becomes equal to 2x to the power of 3 minus 2x to the power of 2 minus 12x. This is our function. Now we compute its derivative, and the derivative becomes 2 that multiplies 3x to the power of 2 minus 2 that multiplies 2x minus 12, which is 6x to the power of 2 minus 4x minus 12. This is the general derivative of the function h. Now we want to compute the derivative in the specific points. So we start from the point x equals to -3. So we substitute to all the x's that we find in the derivative the value -3. And this becomes equal to 6 multiplied by 9 plus 12 minus 12, which is equal to 54. Then we have the point x equal to 0. So we proceed as always. We substitute the number 0 to all the x's that we find in the derivative. And this expression becomes equal to 6 multiplied by 0 minus 12, which is equal to -12. And finally, we have to compute the derivative in the point x equal to 3, which is equal to the expression that you see here, where the 3 was substituted to all the x's in the expression of the derivative. And then this becomes equal to 6 multiplied by 9 minus 12 minus 12. And this is equal to 30. So the final point of the activity was to understand if the function h is increasing, decreasing, or stationary in these points. In the first point, x equals to -3, we find a value of the derivative which is 54, so it's positive, and this means that the function in this point is increasing. In the second point, x equals to 0, the function has a derivative that has a negative value, which is -12, and so the function is decreasing. And finally, in the third point, x equals 3, we find a value of the derivative which is 30, which is positive, and thus the function in this point is also increasing.